The Birthday Problem by Caitlin Arena. How many people must be in a room before the probability that some share a birthday reaches 50%? What are the odds? A person has a 1 in 365 chance of sharing the same birthday with someone else because there are 365 days in a year. When first looking at this problem, I thought that the answer was simple. I thought that the answer would be 183, about half of 365. If the number was half of the number of days in the year, then I thought there would definitely be someone who most likely shared a birthday with you. To solve this problem, you have to find the complement of the event. It would be almost impossible to work from finding the probability of an event because you don't know the chances if someone has the same birthday as you. One important thing to realize is the question does not ask if the person has the same birthday as you, but just if two people in the room will possibly have the same birthday. So the probability of an event happening plus the probability of the complement will equal 1. And the complement is the set of outcomes not included in the event. Okay. At the party, if there are two people at the party, you and another person, then the probability of no one sharing a birthday is 364 out of 365, which equals about 99.7%. This means that the probability of someone sharing a birthday is about 0.3%. We have to get the percentage over to 50 to successfully solve the problem. How many people before this happens? If an event plus a complement equals 1, then 1 minus the probability of an event not happening will give us the probability that the event will happen. As you keep going down a person, the probability of the complement will get smaller and smaller. This means that the probability of the event occurring will get bigger and bigger. When we count up the total number of people that it takes to get the percentage close to 50 as possible, we get 23. And that's by going through the process of subtracting 1 and keeping the same denominator to find the probability percentage. But why? As you can see, it only takes 23 people in a room to have a 50% chance of two people sharing a birthday. This number is much smaller than expected. But why? When you have 4 people in a room, there are only 6 possible combinations of birthdays. This is a combinations problem where n equals 4 and r equals 2. So after doing some more calculations, we see that when 23 people are at the party, there are 253 possible ways of people to share birthdays. So the number actually increases almost exponentially. As you can see, at number 23, the probability hits just about 50%. As well as the people at the party gets bigger, the percent of sharing a birthday gets larger as well. When the number of people at the party gets to 70%, there is a 99.9% chance, or almost certain probability, that there will be two people who share a birthday there. So, in looking up this problem, I wasn't sure what a paradox was. So, after doing some research, I saw that it was a seemingly absurd or self contradictory statement or proposition that, when investigated or explained, may prove to be well founded or true. So, I think that this problem is referred to as a paradox because it is difficult for our minds to think exponentially. The answer seems absurd that it only takes 23 people, but when you think about how the total number of combinations of people increasing as more people attend, I think it makes perfect sense. So, a little bit about the theory at work. As you can imagine, the more friends you have on Facebook, the more annoying notifications you will get asking you to wish them a happy birthday. These people share birthdays all on the same date. So, probability theory at the beginning. Cardano wrote a book in 1550 about games of chance called Liber di Ludo Aleale, which means a book on games of chance. Some consider this to be the start of probability theory. His book was not published until 1663, letting others gain credit for this discovery, Pascal and Fermat. So Pascal and Fermat focused on these two games. One was called Gambler's Ruins. In Gambler's Ruins, each player has a finite amount of pennies. One penny will be flipped from either player. Heads will go to player A, tails will go to player B. The penny goes to the player who has the winning side. This is repeated until one player is bankrupt. The fact that one player must lose all the pennies is certain. According to Wolfram Math, your chances of going bankrupt are equal to the ratio of pennies your opponent starts out to the total number of pennies. Therefore, the player starting out with the smallest number of pennies has the greatest chances of going bankrupt. Even with equal odds, the longer you gamble, the greater chance that the player starting out with the most pennies wins. Since casinos have more pennies than their individual patrons, this principle allows casinos to always come out ahead in the long run. As the common practice of playing games with odds skewed in favor of the house makes this outcome just that much quicker. I think that this is interesting, as a house will never allow a patron to win over them because the house will always have more money. This leads to the question, why are so many casinos shutting down in Atlantic City? It can't be the probability theory at fault. And the problem of points is a winner takes all type of game. It determines how many winnings should be divided when the game is ended prematurely.